For integration, we have this one method called integrating by substitution. Now, the thing with integration is this. As we said before, integration is an art and not mere mechanics. So even though we have this method here, integrating by substitution, the only way you're really going to know when to use it, for the most part, is by practice. I can say offhand that most of the times, we use integration by substitution when we have a composite function. And we also use it particularly when we have the product of two functions where one is the derivative of the other. So let's look at a few examples. Let's say that we have to integrate 3x times the square root of 1 minus 2x squared with respect to x. Now, what I want you to take note of is that there's an x right here and there's an x squared right here. X is just one step down from x squared. So we're going to take note of that. So what we're going to do, we're going to say, alright, u is equal to 1 minus 2x squared. And we're going to say du would be equal to negative 4x dx, which would imply that x dx would be equal to what? Negative du over 4. So here we have x dx and we have 1 minus 2x squared. So we're going to be substituting all of these in the original integral expression that we have here. So what do we get? We get 3 times the integral, because we factored out this 3. The integral of what? X dx would be equal to negative du over 4. So we're going to factor out that too. Put our du. And we're finding the square root. We're integrating the square root of what? 1 minus 2x squared. But what is 1 minus 2x squared? 1 minus 2x squared is equal to u. So it's the square root of u, which is u to the half. So integrating that expression there gives us what? We're given negative 3 over 4 times what? What's the integral? That will be 2 over 3 times u to the negative, times u to the 3 over 2. Plus what? Our constant of integration. Now, if we were to substitute the fact that u is equal to 1 minus 2x squared in that expression, we would have that the final answer would be negative 1, negative open bracket 1 minus 2x squared to the 3 over 2 all over 2 plus our constant of integration. So what did we do here exactly? All we did was that we say, okay, we're using integration by substitution here because we have one function, or we have one expression here that is the derivative of another expression. They share some, what we may call, linear relationship, in that the derivative of x squared is some constant times this here, x. So we're able to exploit that. And we call it substitution because we're going to be bringing in a new variable, and that is the variable that we want to be integrating with respect to. So the other variable that we had here, x, we're going to get rid of all the x's and replace them with u's. So let's look at another example. We want to integrate sine cube x with respect to x. So that would be equal to integrating sine x times sine squared x with respect to x, obviously. Now let's write sine squared x in terms of cos. So that would be 1 minus cos squared x, integrating with respect to x. So what's happening here? We have this product, but remember, I know that the differential of cos, differentiate cos, you get what? Negative sine x. So what am I going to do? I'm going to do a little maneuvering here. I'm going to say, let's put a negative sign here, let's put a negative sign here. Why? Because negative cancels negative. Or let's just say negative times negative gives us positive. So we're going to say u is equal to cos x, right? So that means that du would be equal to what? Negative sine x dx. So we can plug our u here and negative sine x dx right here. So what do we end up with? we end up with negative integral of what? Negative sine x dx was equal to du, you know. And then we have 1 minus cos squared. But cos is equal to u, so that would be u squared. So integrating that with respect to u gives us what? We have negative u minus uq over 3. But what is u? U is cos x. So all in all, this would give us what? Cos, we left out our constant of integration. So this would give us cos cube x over 3 minus cos x plus c. So looking at this, I must mention that whether you were giving sine to the third power, sine to the fourth power, cos to the third power, cos to the fourth power, or anything of that sort, we would use the same principle for anything of that sort.